Right now, a massive gravitational distortion is on a direct collision course with Earth. If we sit and wait, this black hole will consume our entire planet and push humanity to extinction. Our instinctive first line of defense is to throw everything we have at it. We gather up the entire global nuclear arsenal and launch it straight into the darkness. We are talking about a simultaneous detonation yielding energy equivalent to 425,000 times the atomic bombs of World War II. We expect a spectacular explosion to obliterate the threat. Instead, the black hole swallows the blast like a light snack. The radiation and kinetic force completely vanish, and the black hole emerges from the dust even more massive than before. This highlights the fatal paradox of fighting a cosmic void. Traditional weapons rely on releasing massive amounts of energy to destroy a target, but black holes are the ultimate energy absorbers in the universe. Whatever kinetic or explosive force you feed them, they happily consume. Because this object feasts on raw power, we have to abandon our brute force instincts. To actually destroy a black hole, we need to systematically dismantle the physical properties that keep it alive. To dismantle a black hole, we start with the source of its power, its mass. This extreme mass usually originates from immense clouds of gas collapsing, or from a massive star dying. The outer layers blast away, and the incredibly dense core implodes, creating a localized gravity trap. Since we can't blow that mass up with standard matter, we could try the exact opposite. We can manufacture a custom black hole made entirely out of antimatter, matter with reversed electrical properties, and crash it into our enemy to neutralize the mass completely. Creating enough antimatter requires accelerating protons to nearly the speed of light, then firing them into a heavy material like iridium. The impact knocks out fast-moving antiprotons, which we then slow down and harvest to build our weapon in orbit. But when we ram the antimatter black hole into the regular one, the reaction doesn't cancel anything out. Matter and antimatter annihilating creates pure energy, and the original black hole simply vacuums up that energy, growing larger once again. We cannot starve this mass by holding back, and we cannot annihilate it with opposing matter. Since the core density is untouchable, we have to pivot our attack away from the mass itself and target the physical boundaries surrounding it. This diagram shows the absolute boundary around the mass, marked by this bright line, the event horizon. This is the exact radius where the gravitational pull becomes so intense that not even light can achieve the velocity required to escape. Crossing this line has severe physical consequences. The gravity at your feet would be exponentially stronger than the gravity at your head. You would experience extreme stretching and compressing simultaneously, a lethal process formerly known in physics as spaghettification. Breaching or destroying this boundary might cause the black hole to drain out, and physics offers 3 wild concepts to do it. We could inject a repelling white hole, detonate a bomb that explodes faster than the speed of light, or use a wormhole-based time machine to erase the black hole before it was born.
Practically, all 3 concepts are dead ends. We do not have time machines or faster-than-light explosives, and even if we could synthesize a white hole, the resulting collision would release a burst of gamma radiation so intense it would instantly kill anyone close enough to deploy it. Our total ignorance of the precise space-time mechanics inside the event horizon makes it impossible to stretch or puncture. We don't even know if the core has a finite physical size, so we must abandon attacking the boundary and target the external mechanics holding the system together. Look at this wireframe model showing that black holes are highly dynamic objects. They possess angular momentum, meaning they are spinning, and they carry an active electrical charge. For a black hole to exist, it relies on a strict equilibrium. The rate of its spin and the intensity of its electrical charge must remain in sync with its total mass. It's like a marathon runner needing to maintain a specific body temperature and blood pressure to keep moving forward. If we want to break the runner, we mess with the vitals. We can try to artificially overload this equilibrium by amping up the spin and charge so far past their maximum thresholds that the physical system literally shakes itself apart. But there are 2 fatal flaws. If we merely slow the spin, we are still left with an invincible mass. However, if we successfully force the black hole past its physical limits, we risk stripping away the event horizon and exposing the singularity underneath. Without that boundary to contain gravitational forces, we could trigger an uncontrolled release of energy that would destabilize space,
potentially threatening the entire universe. Any human attempt to manipulate a black hole's internal or external mechanics is either going to bounce right off or prove cosmically suicidal. After exhausting every technological marvel and theoretical physics trick humanity can dream up, the black hole is still coming. Every human intervention has failed to put a dent in this threat. This diagram illustrates the only true mechanism that destroys a black hole, relying on a subtle background process described by quantum theory. Throughout the vacuum of space, pairs of particles and antiparticles spontaneously pop into existence, collide, and instantly destroy each other. When this pairing happens precisely on the razor's edge of the event horizon, the rules change. One particle gets sucked into the hole, while the other particle escapes out into space. The black hole loses the tiny bit of energy carried away by the escaping particle, shrinking the overall mass by a microscopic fraction. This process is called Hawking radiation, and it causes the black hole to slowly evaporate. The catch is the unimaginable timescale. For a black hole to fully dissipate this way, you would have to wait several trillion years. Black holes are foundational forces of nature, bound by cosmic timelines that dwarf anything humanity can produce. We can't blow them up, we can't starve them, and we can't manipulate their physics. If one ever sets its sights on Earth, our only viable defense is to pack up and simply get out of the way.